everyone, myself Hemalatha from K.B.N College, Department of Physics and Electronics. Today we are discussing about essentials of physics. So introduction of the physics. Physics is the branch of science that studies the physical world, including objects as small as subatomic particles and as large as galaxies. It is concerned with the nature and origin of force, fields, the behavior of objects under forces, and the physical quantities like length, mass, time and energy. The scope of the physics is very vast and covers three levels of phenomena, that is microscopic, mesoscopic and masoscopic. These levels span from the molecular and atomic level to the terrestrial and astronomical levels. The scope of physics in the modern world. In the modern world, the applications of physics is severally seen. The scope of physics can be classified into different branches like classical mechanics, thermodynamics, electromagnetism, as well as optics. In the modern situations, these subjects deal with the concepts of relativity as well as quantum mechanics. The theory of relativity grows the scope of physics, that is used in the modern world severally. So the physics is divided into two types, that is macroscopic and mesoscopic. Macroscopic is used in quantum mechanics, theory of relativity, and macroscopic is used in mechanics, thermodynamics, electrodynamics and the optics. Applications of physics. The physics has become an inseparable part of an individual's daily life. One important example is the usage of the alarm clock. Different properties of sound, origin and propagation are important parts of a clock. The resistance between the surface of the road and the shoes helps an individual to keep walking without slipping or losing grip. The mechanism of a ballpoint pen is another important application of physics in daily life. The concepts of gravity, a significant part of physics, is concerned to this part. The rolling of the balls helps the link to transfer to the paper as a result of gravity. The significance of physics. The physics plays an important role in almost every working area of an individual. Modern science and technology are also very much dependent on the application of physics. The basic working process of a person is dependent on the application of physics. Walking is also a part of physics in which the motion within the road and a person's shoe is relevant. The concept of thermodynamics, a part of physics, is an important part of the cooking process. In cutting vegetables and fruits also, the pressure of a knife is required. Application of physics is also present here. In closing and opening the door and seeing an object also, physics is very much integrally connected. The measurements and units. Units of measurement are standardized quantities of physical properties that are used to express and compare the magnitude of those properties. Units of measurements were among the earliest tools invented by humans for various purposes. There are different systems of units of measurements, such as the metric systems, the imperial systems and the US customary systems. The metric systems is based on 7 base units, namely meter, kilogram, second per amperes, Kelvin, mole and candela. A common unit of measurement is a quantifiable language that makes the relationship between the item and the measurement clear to all properties. And what is the motion? In physics, motion is the phenomena by which an object changes its position with respect to time. Motion is mathematically described in terms of displacement, distance, velocity, acceleration, speed and frame of reference to an observer, measuring the change in position of the body relative to that frame with a change in time. The branch of physics described the motion of objects without reference to their cause is called kinematics, while the branch studying the forces and their effect on motion is called dynamics. If an object is not in a motion relative to a given frame is reference, it is said to be at rest, motionless, immobile, stationary, or to have a constant or time invariant position with reference to these surroundings. Modern physics holds that as there is no absolute frame of reference, Newtonian's concept of absolute motion cannot be determined. As such, everything in the universe can be considered to be in motion. Newtonian laws of mechanisms. Newtonian laws expressed in terms of linear momentum or laws of inertia. A body remains at rest or in uniform motion unless acted upon by a force. And second one, equation of motion. A body acted upon by a force moves in such a manner that the time rate of change of momentum equals to the force. And the third law is action and reaction. If two bodies exert forces on each other, their forces are equal in magnitude and opposite in direction. Relativistic mechanism. Science concerned with the motion of bodies whose relative velocities approach the speed of light, considering as c. Our whole kinetic energies are comparable with the product of their masses, denoted by m, and the square of the velocity of light, or mc square. Such bodies are said to be relativistic, and when their motion is studied, it is necessary to take into account Einstein's special theory of relativity, as long as gravitational effect can be ignored, which is true so long as gravitational potential energy. What is thermodynamics? Thermodynamics in physics is a branch of that deals with the heat, work and temperature and their relation to energy, radiation and physical properties of matter. To be specific, it explains how the thermal energy is converted to or form another form of energy and how matter is affected by this process. Thermal energy is the energy that comes from heat. This heat is generated by the momentum of tiny particles within an object, and the faster these particles move, the more heat is generated. And the laws. Thermodynamics laws defines the fundamental physical quantities like energy, temperature and entropy that characterize thermodynamic systems with thermal equilibrium. These thermodynamics laws represent how these quantities behaves under various circumstances. And the thermodynamics laws is divided into four types. There are zeroth law of thermodynamics, first law of thermodynamics, second law of thermodynamics and third law of thermodynamics. And firstly we have discussing about the zeroth law of thermodynamics. And the zeroth law of thermodynamics states that if two bodies are individually in equilibrium with a separate third body, when the first two bodies are also in thermal equilibrium with each other. We have to take the example. If the system A is in thermal equilibrium sorry, with the system C and the system B is also in equilibrium with the system C, then the system A and B are also in thermal equilibrium. Consider the two cups of A and B with boiling water when a thermometer is placed in cup A. It gets warmed up by the water until it reaches 100 degrees Celsius. When it reaches 100 degrees Celsius, we say that the thermometer is in equilibrium with cup A. When we move the thermometer to cup B to read the temperature, it constitutes to read the 100 degrees Celsius. The thermometer is also in equilibrium with cup B. By keeping in mind the zeroth law of thermodynamics, we can conclude that cup A and cup B are in equilibrium with each other. The zeroth law of thermodynamics enables us to use thermometers to compare the temperature of any two objects. And second one is first law of thermodynamics. The first law of thermodynamics is also known as the law of conservation of energy. States that energy can neither be created nor destroyed, but it can be changed from one form to another form. For example, plants convert the radiant energy of sunlight to chemical energy through photosynthesis. We eat the plants and convert the chemical energy into kinetic energy while we swim, walk, breathe and scroll. Switching on light may seem to produce the energy, but it is electrical energy that is converted. And third one is second law of thermodynamics. Second law of thermodynamics states that the entropy in an isolated system always increases. Any isolated system spontaneously evolves towards thermal equilibrium, the state of maximum entropy of the system. For example, if a room is not tidied or cleaned, it invariably becomes more messy and disorderly with time. When the room is cleaned, its entropy decreases. But the effort to clean it has resulted in increased entropy outside the room, exceeding the entropy lost. And next is acoustic wave and electromagnetic waves. Acoustic waves is also called as sound waves. In modern day world, there are many scientific and technically applications of different kinds of waves. Most of such applications use sound waves or electromagnetic waves. Sound waves are mechanical waves, whereas electromagnetic waves are not mechanical waves. Therefore, sound waves requires a medium for their propagation, whereas electromagnetic waves do not require a medium. This is the main difference between sound waves and electromagnetic waves. The sound waves are mechanical waves produced by mechanical vibrations. For example, when your phone rings, it vibrates its surroundings, generating compression and rarefaction in the air. These compressions and rarefaction propagation through air. When they reach our earbuds, they cause the earbuds to vibrate. This is what we perceive as a sound. They require a material medium for the propagation as they are mechanical waves. Therefore, sound waves cannot travel through a vacuum. Sound wave propagation through air, liquids and plasma as longitudinal waves. In solids, on the other hand, sound waves can propagate as both the longitudinal waves and transverse waves. Anyhow, the speed of sound depends on the material properties. In the air, the speed of light increases with the temperature. Sound waves mainly characterized by their pitch, loudness, and quality. And electromagnetic waves. Electromagnetic waves are produced by accelerating or deceleration charged particles. There are transfer waves. As a result, electromagnetic waves are polarizable. Electromagnetic waves, unlike any other type of waves, contains a magnetic field and also an electric field oscillating perpendicular to each other and perpendicular to the direction of propagation of the waves. These waves carry energy in the direction of propagation of the wave. They can propagate through a vacuum as they are not mechanical waves. For example, the frequencies of electromagnetic waves have an extremely broad range. The properties of waves depend on the frequency, amplitude, etc. Therefore, for our convenience, electromagnetic waves are grouped into several bands, namely radio waves, microwaves, infrared waves, light, UV, X-ray and gamma rays. Altogether, the entire range is called the electromagnetic spectrum. And electric field. An electric field is the physical field that surrounds electrically charged particles and exerts a force of all other charged particles in the field, either attracting or repelling them. It also refers to the physical field for a system of charged particles. Magnetic field. The magnetic field is the area around a magnet in which the effect of magnetism is felt. We use the magnetic field as a tool to describe how the magnetic force is distributed in the space around and within something magnetic in nature. And we are discussing about atom. Atom is the basic of all matter. They are very small and consist of even tinier particles. Neutrons, protons and electrons are the basic particles making up the atom. They join together with the other atoms and create the matters. It takes many atoms to create anything. Atoms are extremely small, typically around 100 picometers across. A human hair is about a million carbon atoms wide. This is the smaller than the shortest wavelength of visible light, which means humans cannot see atoms with conventional microscopes. Theories and understandings of universe. There are 4 theories popular regarding the universe. Of these, only 2 are commonly accepted: the Big Bang and inflationary theory. And Big Bang theory. The Big Bang suggests that around 10 to 20 million years ago, a massive shock wave allowed all non-energy and matters in the universe, including the space and time, to emerge from some unknown type of energy. The theory continues the assure that after the total collapse, a new expansion will follow, another Big Bang, and so indefinitely in an infinite series of Big Bang and big crash that would also justify an infinite number of universes. However, this theory does not go into explaining the causes of the Big Bang itself. Inflationary theory. In the original formulation of the Big Bang theory, several unsolved problems remained. At the time of the explosion, the state of the matter was such that customary physical laws could not be applied. Thus arose this theory that was developed in the early 1980s by the American scientist Alan Guth. Cosmic inflation explains how an extraordinarily dense and hot particle that contained all the mass and energy of the universe, being smaller than a proton, is released outward in an expansion that continues in the millions of years that have elapsed since then. Steady state theory. The steady state modules was proposed in 1948 by Hermann Bondi, Thomas Gould, and Fred Hoyle. Bondi and Gould presented a philosophical decision involved the so-called perfect cosmological principle, in which a universe, in addition to being spatially homogeneous, present the same average aspects at any time. According to the steady state theory, the cosmos have always existed and will always exist. The essential point of this explanation is the fact that the universe, despite its expansion process, it also maintains the same density thanks to the continuous creation of new matters. And universal mind theory. The expansion of the universal mind or universal consciousness relates to a concept of metaphysics which suggests that there is an underlying force that binds us all into becoming a single universe. The theory refers to the creation of the universe and the experience of becoming a being. These are processes that occurred prior to the arrival of consciousness of the mind. Thank you.